Okay, so hello and welcome back to another shader tutorial. In this one we're going to be doing a 2D shader, though you can always apply the same effect to 3D. Though I won't be covering that, but you know, you should be able to change from 2D to 3D. In this video, as you can see, we're making I don't know what to call it really, but I guess it could be kind of like a teleportation thing. Like you might run up to something in your game and there might be a teleport pad and you step on it and then it does the whoosh down effect, for example. You can do what you want with it. I just think it looks pretty cool. I'm going to mention a few things this video before we make it. One thing is, someone said about weirder things when you flip your sprite from left to right. Now, first of all, with the shader graph, since it's a new thing and there's quite a few bugs and just unfinished parts of it, because it's still in like early release, if you try and flip your sprite, it just kind of disappears, because what actually happens is it doesn't flip it properly. It actually just rotates it, and it doesn't work properly. And it also says like the main text property is missing, even though if you go into debug mode down here, main text is actually still here. There's just a few problems with shader graph. So I guess for now you can't really do much about it unless someone actually comes up with a solution online. I've looked around and there's not really been any solutions for it. People are just saying, you know, wait for them to fix it. So I guess you can just be patient. Like on my game, I haven't upgraded to the new version to use shader graph yet because I don't want to make my game in the low render pipeline. But anyway, and the one other thing that was asked to be discussed was quickly how to do the normal map. So I don't actually need to do it, I could just show you it because it's very simple. In this, I'll link this in the description, it's the shader graph tutorial pack. I've made this one, but if I go to, which example scene is it? Maybe it's this one? Nope, this one. Here we go. So here are some of the Ellen ones. These are like the ones they gave by default. Those two are still messed up. You can fix those yourself. As I said, there's quite a few problems with the missing things. But here's the normal one. So like normally, if a light goes near a sprite, it just kind of like, let's bring the light up here, and you'll see the difference. So this kind of just lights it up as like a 2D image, though a normal is like a height map, so that, for example, you would expect on this image the front leg to be, you know, closer than the back leg. And like if you actually bring the light around here, rather than lighting it up in 2D, I know it looks pixelated because it's, well, a sprite, and if you zoom out you can't tell. But it correctly lights the image, so like obviously the underside of the leg, and on here, when you bring it up above the leg, the underside doesn't get lit. And that's because, well, for this to work, you would have to actually have a normal map. So here's the normal map for the Ellen thing. As you can see, like the darker areas and the lighter areas, and that just lets the lighting know where to shine, I guess. And if you go into the sprite and you go see, this uses the normal map shader which they've made. So if I search normal and I bring it over here, this is all they've done. So they've taken the normal map, which is the like weird blue looking thing, and they've put it into here because it takes in a texture, you know, so it says T, but it gives out, well, the normal requires a vector 3, and the actual thing is you can put a vector 4 into a vector 3 and it just ignores the alpha value, so it does the RGB, and that gives you this height map. And then if you, the reason we have these other two is for cutting out the weird stuff on the material so that it actually works as a sprite sheet. And then obviously the albedo is the main like texture. This thing that says subgraph sprite sample comes with the pack, and a subgraph is literally just, it's literally like a subroutine. It kind of just does all of this to your inputs and gives these as two outputs. So you get the RGB and you get the inverted colors, which allows you to cut out. Think of it as like you've got a sprite sheet with loads of extra mush around it, and this kind of cuts it out and ignores it. So for the height normal map, this is all you need with your texture. And the last little bit before we make the shader is, someone said, is there a way for you to just automatically use the material the sprite sheet you put in here? And I don't think there is actually, because let's say we ignored this input stream and we put none. As you can see, it looks a bit odd because what it does is it uses, since we pass in a sprite sheet and it looks like, well, let me just go back to the Ellen thing. Obviously this is Ellen run. It's still, even though it's only drawn like this, it still reads it as like this. So we still get all this like mess here. Now what the shader does when we pass in the sprite sheet is it cuts out this bit. So if we don't pass it in, it won't cut it out, and that's why you get the really weird looking things like this. This is like Unity doing its best to cut around the sprite, but as you see, like on its foot, it doesn't perfectly go around the foot, it just kind of takes a big chunk out of it. It's like when you use a mesh collider. I think actually if we did just like, for example, quickly put on a mesh collider, that's what it would look like maybe. Wait, did I mean mesh collider? It's polygon collider, sorry, for 2D. Oh, no, that actually does it very well. That looks like it's already been pre-made. But anyway, that's what it does when it cuts out. And sorry, I've been doing quite a lot of rambling. Obviously, you could have skipped this part if you didn't want to listen to this. But this was answering like 2 or 3 people's questions, so I felt like I needed to do it. Let's get into the video now. So scene 4 is where I'm doing it, I think. Yeah. So here's Ellen, and here's the material from last time. So let's just, well, first of all, I can delete the one I've just shown you that I've been testing around because I'm going to remake it. And so yeah, as always, obviously create a new material. I'll just call it teleport mat. You can do whatever you want with these. Obviously that looks odd because it reads the whole outline bit. And we need to make a shader. When I showed you earlier the little subgraph, like subroutine kind of shader thing, that is here, subgraph. But we're using PBR graph for a normal shader, so I'll just call it teleport shader. I'm not very good with the namings of things. Alright, and obviously that just gets rid of it completely. Now, what do we want here? There's going to be quite a lot of stuff. So to make it work like a normal, like the first thing you have to do on every sprite related shader is you have to take in the sprite sheet, as I've said. Maybe they'll make a way around this in the future, but I don't think this is something they'll be able to change. Maybe they will. So let's call it sprite sheet. And for the preview, we'll take it in, Ellen run. And then we'll do the sprite sample subgraph to help us just take this mush, of a material, and output this to the alpha clip and make the alpha 0.5 so we can actually, whoops, 0.5. Now we've got our material cut out, the bits of the sprite sheet, and then we put the texture into it. And if we saved, it should go back to looking like normal. This is basically what the normal shader is. Obviously we would still have to actually put in the texture down here. There we go. That's normal now. Okay. Next, we want to do the moving up and down of the animation thing. Now, for the sake of this, what I'll do is I'll put in a value that you can change yourself, but then, well, actually, no. I'll show you how to do that. You should be able to figure it out, but I'm just going to use time for now. So let's create time. I like using the time one because it kind of animates it for you rather than having to change sliders. And what we need is we need a remap. And the reason we need a remap, if you don't know what this does, is it basically takes in a value, and rather than, so sine time, for example, a sine graph goes between 1 and -1, but that value, those values don't go high or low enough for our like sprite. Now I've used this sprite before and it goes between like 2.5 and -2.5. So what I can do is I can put in the in, and as you see it says like the sine goes between -1 and 1, and it's going to output between -2.5 and 2.5. Now all that's going to seem like is happening is this is speeding up, because in the same amount of time it's going between a higher and a lower value, but you'll see why this is useful in a second. Now we're going to get a step, and as you should know already, step kind of, if the value is it higher than or equal to, I always forget which one it is, or it's higher or lower. Returns 1 if it's higher than or equal to, yeah, I was right, okay. So let's put that into the in, and then to know what the edge is, we have to get the position in our world, because, no, sorry, not the world, we need the position of the object. If we get the position of the world, what will happen is, when we move the object up, it will have the effect move as well. We kind of want the effect to be on the object rather than in the world space. Maybe you want some shaders to be in world space, like water. If the water is going to stay the same and the player is going to go in the water, then you might want to change it, for example. Now we want to split this, because we don't want a vector 3 for this, we want a vector 1. So let's just put a vector 1 in here. And as you see already, we've got the kind of basics of the moving up and down. But as you'll come to see, there's some problems with this. Let's say we just instantly went and well, we can't really put it in the alpha clip because what will happen is we'll lose the cutout and it'll just move up and down like this. And if you really want to see what this looks like, it's very stupid. Don't know why you'd ever want that, but that's what it does for now. And if I didn't have this remap, the line wouldn't go all the way down to a bottom foot, and it wouldn't go all the way up to the head. It would kind of just go in between. It doesn't look right. Remapping values, you want to put in the values that are right for your shader. So you might not want 2 minus 2.5 and 2.5. It's what's right for this sprite sheet. Anyway, let's not have that there. We will have it going in there later when it's done. What else do we want? Well, let's get another step, because first of all, we've got the value for the moving up and down thing, but we want to cut that out of our sprite, but not the whole material, because obviously we don't want to do anything with this bit that we're already ignoring. We've already cut it out here, so we want to, with this step, we want to take in the output of this. So obviously that's not going to look like anything just yet, and we want to unhook this into here. Whoops, I missed. Sorry, let's put that there. Now as you see, what does this look like? Ooh. So this looks the same, but instead of just the black, we also have the actual sprites. Now, if you didn't already guess, let's go and put that into the alpha clip threshold. And now, that isn't right actually. Wait, did I not invert it? Sorry, I think I've missed a step. There was a problem. I've put something in the wrong place. I have put this into here, and then this goes in here. Sorry, I'm an idiot. Anyway. Now, oops. Now this works. So there's the effect. It's lagging a little bit for some reason. But as you see, it goes up and it goes down. Now, you could be happy with this, but like the last one, edges just having been cut off doesn't look very good. We want to have a kind of like smooth like gradient on the edge for the thing. And the way we do this is slightly different to the last video on shaders, where we have the edge, sorry, I'm just making space, where we have the edge, we subtract a small value from the actual outline, well no, from the thing, so we get an outline, and then we can apply a color to that and have a cool rim glow. But for this it's slightly different. First of all, we want to actually take in a value for the edge, like how much do we want, so I'll put edge value. And we want it quite small, so let's put 0.1. That might not even be small enough, to be honest. And we're going to add that. We're going to add the edge value. I'm going to zoom in. Just make some space. Okay, so we're going to take the edge value and we're going to add it to the remap value from down here. So we're going to come out of here. Boom. And, oops. It doesn't really matter which A and B is, because as you know, adding two numbers doesn't matter what order you do it in. I really just want to make more space here. That's one thing I need to get better at. So now that we've got this slightly kind of offset of this, though we might want to lower the value a bit more, we're going to add a smooth step. Now, if you didn't already guess, a smooth step is the same as a step, but instead of having a harsh cutoff between 1 and 0, it has a gradient. So it goes between 1 and 0, but not just 1 or 0, it's all the values in between. So you'll see when we put it in, it actually looks a lot smoother. We want to take the output of the remap to the edge, and to the G from here. Oh, see daisy. There we go. Now, I don't know any ways of making this less messy. I mean, it's on screen, so you can pause and see what goes where. So what the smooth step does is, it has a line slightly offset from where this line is on the actual step, but it also has a gradient around it. And what we can do, if you didn't already remember, we can apply a color to a gradient. So this will basically mean that on the edge of our going up and down, we'll have a color. Though, one thing to remember, which I say all the time, but you need to get it drilled into your head if you don't already, in shaders and color in general, white is 1 and black is 0, and 1 means something and 0 means nothing. In most cases, pretty much every case. So here, what will happen is if we apply a color, it will apply it to everywhere but the edge that's moving up and down. So what we'll get is it will change our sprite's colour, but the edge will be the actual sprite. We want it inverted, and one way to invert ones and zeros is to do 1 minus. So if we have a 0 and we do 1 minus 0, it'll be at 1. If we have a 1 and we're taking in a 1, it'll become a 0, and every value in between, and so on. So let's do 1 minus, and as you see, we get the invert that. And I feel like it's such a high value, we need to actually lower this to like 0.05 maybe. See how that looks. That might still be too much. We will see. Now, obviously, as I said, we want to have a color for this. Well, we want to be able to change the color, so we'll add a parameter color, so like edge color, and we'll choose green. Why not? Actually, I don't like green. I'll go purple. I think purple looks cool on these kind of things. We'll take in the color, and as I've said plenty of times, if you multiply a color by something with white and black, all the white bits go with the color. So there we go. Now we've got like a cool pink kind of glow up and down. And if we add that to the emission, that'll emit that color at the edge. It's very hard to see on here, so we're going to save it. We're going to go back into here, and let's just tweak the values. So edge value. Ooh, let me just go back up. So I want the edge value maybe like this. There we go. Okay, that seems to work right about -0.14. I'll see when we change the color. Like, let's say I had like a red teleport. Well, red doesn't. You can't really see it stand out on this much. So blue's quite nice. Obviously, you can change the value as much as you want, but I'm gonna assume that you want the value when it's at the top to be like not really visible. So -0.24 for this, maybe 2.27. I really like that effect. Let's go into here. So like as the thing comes down, it glows around it, and obviously you could have more of a glow. You could actually have the edge kind of stronger than this. Obviously I've used a gradient, but you can always change values and tweak what you want. Keep in mind this isn't the only way to do this effect. Like there's always plenty of ways to do different effects. So generally, as usual, I'll do a quick run over of what everything does. So we've taken our sprite sheet and we cut it up so that we get rid of the stupid mess of a material, and we just have a sprite sheet kind of material, like specialized for 2D sprites. But we actually use the, let's see which value it is. Sorry, we use the alpha part to with our step to know which bit of the sprite we're showing and which we're not. And the way we decide that is, in this we use the sign time, but you can also use a slider to change the value. Down here, as the time goes up and down, it goes between -2.5 and 2.5 instead of -1 and 1, because that isn't enough. That value then decides, like, you know, it goes up and down, like, because of the time up and down, how much gets cut out. Obviously, you can have a slider here to choose up and down. We also output this to 3 places. We output it to the step. We output it to the add, because we add to it to have a slight offset. Obviously, the edge value is the offset. And then we use a smooth step to get a nice gradient at the edge, so that we can like have a cool like color kind of gradient going down as we come away from the edge. And then we 1 minus to invert it, because otherwise the color would be applied to the main body of the sprite and not the edge. So that obviously inverts it. And then we multiply over color to have a pink edge, or whatever color edge you want. And then we ended up putting this as the emission, so we emit that on the edge. And then we have the cut out here, and it's all synced up by this time node at the start. So. I hope you enjoyed this video. I think this is a pretty cool effect that I like making. I hope I answered the questions well enough at the start of the video for those people who asked those questions. Obviously, some questions can't really be answered or fixed yet until Unity themselves fix the thing, but it's only been out for a little bit, so, you know, give them some time. I really like what they've done so far with the shader graph, because I've learned a lot about this and how to implement like normal maths to make really cool looking visuals. If you've got any questions, obviously ask. If you want to see more shader videos or Unity in general or Python or whatever, as always, just please like the videos you want to see more of, comment asking what you want more of if you want help. Subscribing would also be lovely. And we have a Discord channel in the description, which you can join to talk to other people that view this channel about anything you want, really. We've got like different channels for our different things. I can't actually really, well, I can show it. Here we are. We've actually got quite a few members now that have joined. We have different text channels for Unity, blah 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 blah, all the different ones. I'm gonna see, since I've got quite a free day today and it's only 11:30, I'm gonna try and make 2 more videos today, whilst also having time to do what I want. But yeah, I'll put the link in the description to join the server. Here's the finished thing. Here's what it looks like. Anyway, I hope you enjoyed the video. Thanks for watching, and goodbye.